For the synthesis of heterocycles and the journey of Baldwin's rules for ring closure. So in medicinal chemistry, in organic chemistry, most of the compounds are heterocyclic in nature. If we want to synthesize these compounds, then how can we synthesize such compounds? So we can synthesize such compounds by the ring closer because naturally, as the name suggests, heterocycles, so they are having a cyclic ring structure in their rings in their structures. If it is a one ring, then we used to call them as monocyclic compounds. If there are two rings, then we used to call them as bicyclic compounds. So depending upon whether it is monocyclic, bicyclic, or tricyclic, if they have three-membered rings, then they may be called as, let us say, tricyclic. Four-membered rings, four cycles are there. We used to call them as tetracyclic. Five cycles are there, pentacyclic. So this way, depending upon the number of cyclic rings, these compounds are there. So how these compounds can be synthesized? These compounds can be synthesized through a specific phenomena, what is called ring closure. So friends, this ring closure is more important. नेचुरली साइक्लिक कंपाउंड है तो पहले ए साइक्लिक स्ट्रक्चर होगा और उसमें से फिर दो टर्मिनल्स के बीच में रिएक्शन होके वो साइकिल बन सकता है. नेचुरली इट इज क्वाइट ऑब्वियस. So Baldwin was one of the person. These are the things we have to refer for this presentation, history. How does Baldwin's rule came into the existence? Somehow kind of introduction, nomenclature, rules for ring closure, basis for Baldwin's rule, and cyclization preferences. So this we have to understand in this regard. He is a person, Sir Jack Edward Baldwin. He was a gentleman who proposed for the first time certain kinds of rules, certain kinds of sets of guidelines for the synthesis of heterocycles. Certain rules he has proposed. Rules are much easy to understand. एक बार आपका concept आपके mind में बन जाएगा, बैठ जाएगा, and you will remember it for longer period of time, and it is easy to remember. Certain sets are there or not. जैसे कि if I tell how to reach to Qutub Minar from LM College of Pharmacy. So what you may do, you may search on Google. My location LM College of Pharmacy. Destination is Qutub Minar. How to go there? तो कैसे कर पाओगे आप कर पाओगे यू मे गो बाय फुट. चल के जाओगे उधर, चल के जाओगे तो 1 महीना लग जाएगा और वापस आओगे तो 2 महीने. तो पद यात्रा आपकी वहीं से हो जाएगी, LMCP टू कुतुब मीनार. अनदर ऑप्शन इज यू गो बाय योर व्हीकल, बाइक पे या साइकिल पे जाओ. चलो, फुट से चलने से ज्यादा है साइकिल पे जाओ. साइकिल से अच्छा है बाइक पे जाओ. बाइक से अच्छा है कार लेके जाओ. हाँ, मस्त इस एयर कंडीशन कार है, you for you that is full of diesel, full of your fuel, and you are enjoying air conditioned car, listening the music or ghazal whatsoever. You are enjoying your journey from LMCP, from Ahmedabad to Qutub Minar. Another alternative is you may go by train. ओके, बट ट्रेन का भी रिस्क है. कोरोना में आप जा नहीं पाओगे क्योंकि बहुत ही क्राउडीनेस होता है. देयर इज अ रिस्क ऑफ इन्फेक्शन. You will not prefer to reach there by train. Another option is by air. You may go by flight from Ahmedabad to Qutub Minar. तो ये भी पॉसिबल है, फ्लाइट तो वहां पे उसके स्टेट में जाएगी, फिर वहां से आप जा सकते हो कुतुब मीनार तक, up to airport and then. But if I say so this way, there are several options are available to reach to Qutub Minar from LM College. Okay. So which one will you prefer? You will prefer most preferably by aeroplane. It will save your time. You will be able to enjoy your journey, but it will be little costly to you. ठीक है, वो उतना मुफ्त में नहीं होता है. मुफ्त में करना है तो फिर चल के जाओ. There will be no cost to you. But no one will prefer to walk this much distance, this much kilometers in miles or distance in miles. Okay. So same way, this gentleman, Baldwin has proposed. What he has proposed? A certain kinds of sets of rules, a certain kind of guidelines that whether this kind of cyclization is possible or not, that he has proposed. And from he was born on 8th of August 1938 in London. He studied the biosynthesis of penicillin, and also many of these compounds to solve the laboratory or to solve the synthetic problems in his lab. So he has studied all these things and he could discover all this. This is the work of his impact. For the first time, around 45 years ago, अभी तो ये और 40 साल से भी ज्यादा हो गया है, he has published 2 research articles of chemical communication of Royal Society of Chemistry, and these 2 articles are highly cited. 40 साल के बाद भी उसने जो अपना काम किया था उसका आज भी बहुत वैल्यू है. नंबर ऑफ साइटेशंस आर मोर देन, अभी तो ये 14 1500 1600 से भी ज्यादा होगा. दिस डेटा इज ऑफ 2011, अभी तो 2020 चल रहा है. दिस ये तो अभी इट विल बी मच हायर. ओके, so back to back 2 papers he has published in Chemical Communication 1976, volume number 18, page number 734 to 736, और उसी में 736 to 738 back to back 2 papers in this journal on rules for ring closure, or these rules become much popular by his name, which are called as Baldwin's rules. और तो बाल्डविन नाम में भी बाल्डनेस है उसके सर पे, उसके उसके लिए तो नाम नहीं पड़ा होगा बचपन से ही. His first name, his surname is Baldwin. Surname, last name is Baldwin. Friends, these are the rules which are a kind of guidelines, kind of observations, or rational design of cyclizations. And they will ensure some qualitative set of generalization on the probability of a ring closure. It is a kind of qualitative set, means whether cyclization will occur or cyclization will not occur. जैसे you might have heard about called ज्योतिष. क्या करते हैं वो आपके हाथ की लकीरें देखते हैं, यहाँ ये सारे आपकी हाथ की लकीरें हैं. हाथ की लकीरें देख के they used to discuss with us or they used to tell us कि हाँ आपका फ्यूचर अमेरिका में है, आपका फ्यूचर बहुत धनवान बनने का है, या फिर इस तारीख को ऐसे समय पे आपके लाइफ में प्रॉब्लम आएगी। ऑल्दो आई डू नॉट बिलीव इन एस्ट्रोलॉजी, और मैंने कभी अपना हाथ किसी को नहीं दिखाया है और कभी नहीं किसी से सुना है, पर ये उनका एक ज्योतिष विद्या है, एस्ट्रोलॉजी साइंस है। तो आई एम नॉट चैलेंजिंग दैट ऑल्सो, बट वो ऐसा देख के बता सकते हैं, दे कैन प्रेडिक्ट। कभी कभी वो सही होता है, कभी कभी वो गलत होता है। वो दैट मे वेरी फॉर डिफरेंट डिफरेंट एस्ट्रोलॉजर्स और सेवरल पर्सन्स ऑल्सो। कोई लोग होते हैं और ज्योतिष विद्या में बहुत मानते हैं, छोटा सा भी काम करने से पहले वो हमेशा ही सजेशंस लेते हैं एस्ट्रोलॉजर्स की। આપણે ત્યાં કે લગ્નના મુહૂર્ત જોવાય તો ત્યાં સમય ને ઘડી શુભ હોય તો જ લગ્ન થાય, નહીતર પછી કે ના અત્યારે ના થાય, અત્યારે ખરાબ કાળ ચાલે. So point is to that, tell you sometimes it may be true, sometimes may not be. Baldwin rules are also certain kinds of rules like this. Sometimes reaction may work and sometimes बाल्डविन ने बोला है कि रिएक्शन नहीं जाएगी, फिर भी रिएक्शन जाती है. आई विल शो सम एग्जांपल्स टू यू वेयर these things are there. So these rules are not applicable to second row elements of periodic table. Yesterday we have seen one of the periodic table. Okay, उसमें second row of periodic table who are there, such as this lithium, beryllium, carbon, nitrogen, oxygen, neon. To this second row, with all of them are second row of periodic table. So to these elements, Baldwin's rule is not applicable. It is not applicable to pericyclic reactions. Examples are electrocyclic reaction, sigma-tropic reaction, cycloaddition reactions. So to these reactions also, Baldwin's rule is not applicable. It is not applicable to some of the cations, which are such as lithium cation, sodium cation, or maybe potassium cations. It is not applicable to this thing. जीपैट का ऑप्शन होता तो आपके लिए ऐसा क्वेश्चन होता कि फॉलोइंग विच ऑफ द बाल्डविन्स रूल इज नॉट एप्लीकेबल. Identify second row of periodic table, pericyclic reactions, cations, all of the above. You will tick mark all of the above and will get the full marks 4. गलत होता तो -1. तो जीपैट और पीजी सेट के एग्जाम में ऐसे क्वेश्चन होते हैं, पर एमफार्म में आपको ये पता लगाना चाहिए why these elements of second row of periodic table are not following Baldwin's rule. Why pericyclic reactions does not follow Baldwin's rule? The same with cations. वो तो आपके अभी तक के लिए जीपैट के लिए इतना था, पीजी सेट के लिए इतना था. जो भी टिक मार्क करो तो +4, नहीं गलत करो तो -1, और स्किप कर दो तो 0. Here we should identify that. So how can we do this thing? Okay. So for that we need to learn this. We need to learn Baldwin's rule. We need to identify the things. We need to understand the basics. और उसके बाद हमें पता लग सकेगा whether Baldwin rule can work or not. Okay. So let us go to this nomenclature of Baldwin rule. Basically, Baldwin rule has nomenclature in terms of exo, in terms of endo. What is called exo? What is called endo? So as evident from this image, whenever cyclization occurs, so something will be called nucleophile. So there will be something called a nucleophile, okay? And it is having positive charge, affinity towards the positive charge. That is called nucleophile. Such as examples are Cl minus, Br minus, iodide minus. CO3 minus 2, HCO3 minus 1 or HCO3 minus 2. These all are nucleophiles. तो आपके इस केस में यहाँ पे जो X है ना, that is the nucleophile, or maybe other internet, other term may be electrophile. Electrophile means a substance which is having philicity towards the oxygen. Itself is being electrophile, it is itself positively charged. Cation, sodium, potassium, or carbocation, carbonium ion, all of them are, we can call them as cation or electrophile. The reaction between electrophile and nucleophile can occur. So during this cyclization, if the bond which is breaking, if it is outside of the ring, then it is called as exo. Okay. So here you see, this was a double bond. Because of this, double bond become single bond. तो ये जो बॉन्ड यहां से टूटा है वो रिंग के बाहर है, इसलिए उसको बोलते हैं एक्सो काइंड ऑफ क्लीवेज। ठीक है, यहाँ पे जो देखो रिएक्शन इज हैपनिंग एंड देयर इज अ फॉर्मेशन ऑफ दिस साइक्लिक रिंग। हियर दिस सब्सटेंस हैज अटैक ऑन दिस टर्मिनल कार्बन, जो बॉन्ड टूट रहा है दैट इज अ डबल बॉन्ड, but now it is a single bond. But this bond which is undergoing breakdown, that is the part of the ring. So that's why it is termed as endo. Exo and endo, we have to understand these two prefixes. The bond which is going under breakdown, if it is outside of the ring, then it is called exo. The bond which is undergoing breakdown, if it is either part of the ring or if it is inside of the ring, it is called endo kind of cleavage. Exo का मतलब बाहर और endo का मतलब है inside. So I hope that I am able to make you clear about this prefixes of endo and exo. Okay. So if it is clear, then we can move forward. Suffixes. So what are the suffixes? So we know that any hybridized carbon will have hybridization. This hybridization may be sp3, it may be sp2, or it may be sp. ये तो पता है ना, जिस hybridization, that orbitals which are having similar size, similar shape and similar geometry, orbitals having different size, different shape and different geometry, they club with each other and will make symmetrical orbitals having similar size, shape and energy. That is what called hybridization. Hybridization are of maybe so many types: sp, sp2, sp3, dsp2, dsp3, or so many others kind of hybridization is available depending upon which kind of orbitals are taking part into the hybridization. Okay, so in our case, this tetrahedral carbon is having sp3 hybridization, which is having tetravalent carbon. So you may know that simple example of methane, which is having tetrahedral nature. Okay, so that is also can be considered as a sp3 hybridized carbon. So carbon which is having 4 valency, carbon present at the center of this tetrahedron, and 4 atoms are present at the corner of this tetrahedron. This is a beautiful chemistry of tetrahedral carbon. trigonal carbon, sp2 kind of carbon, which is basically a carbon carbon double bond, two double carbons which are connected with each other through carbon carbon double bonds. That is called trigonal sp2 carbon. Diagonal, if there is already one more double bond, one more bond, that is called triple bond. In that case, the geometry will be sp kind of hybridization state. In this way, these prefixes which are going to indicate whether it is uh, tetrahedral, diagonal, or dig. So, these what are these? Tet stands for tetrahedral, trig stands for trigonal, and dig that stands for diagonal. So, we have to see the geometry of the carbon which is undergoing cyclization. So in our case, this carbon that is undergoing cyclization. Okay, so we can see what is that? That is a CH, a carbon which is having 4 valency. So 4 valency, hence it is sp3 hybridized carbon, hence it is tetrahedral, or tetrahedral is termed as tet. Okay, so this way terminologies are given. Similarly, look at to this. फिर उसमें भी ये होता है कि जितने मेंबर का रिंग होता है उसको भी दे आर गिविंग द नॉमेनक्लेचर. 3 मेंबर की रिंग बनती है तो उसको 3 लिखते हैं. इफ इट इज 5 मेंबर रिंग देन दे आर मेंशनिंग 5. इफ इट इज फॉर्मिंग 6 मेंबर रिंग देन उसको बोलते हैं 6. ओके, so this is more important with respect to the number of ring framework which is going to be constituted. So how to give this nomenclature for cyclization of the rings? So let us understand that first. NH2 is a 1 carbon, CH2 is a NH2 is a 1 unit, this is another atomic, this is third. तो NH2 का अटैक होता है 3 नंबर वाले कार्बन पे, Br चला जाता है, तो it is going to make 3 membered ring, इसलिए उसको बोला है 3. Bond which is going breakdown, so between this carbon and bromine, this bond is breaking, which is outside of the ring, hence it is called exo. Geometry of this carbon, which is present here, unit number 3, carbon number 3. So that is sp3 hybridized carbon. And sp3 hybridized carbon are always called as 3-exotet. So that's why they are called tetrahedral, and the name of this nomenclature, name of this cyclization, that is 3-exotet. 3 क्यों? क्योंकि 3 मेंबर्ड रिंग बन रही है. एक्सो क्यों? क्योंकि बाहर का जो बॉन्ड है वो ब्रेक डाउन हो रहा है. टेट क्यों? बिकॉज दिस कार्बन विच इज sp3 हाइब्रिडाइज्ड कार्बन, इसलिए उसको बोलते हैं टेट. Let us understand the another instance. 5-exo ring. This is of oxygen 1, 2, 3, 4, and 5. Oxygen is attacking on this carbonyl carbon, and this bond is moving towards the head of positively charged oxygen. So it will make a 5-membered ring. 1, 2, 3, 4, and 5. So that's why the name is 5. So 5 इसीलिए दिया है because it is 5-membered ring. Why it is called exo? It is called exo because this bond which is going breakdown, ये जो double bond आगे जाके single bond बन जाएगा. So that is because of this. That is not the part of this ring. That's why it is termed as exo. Okay. Why it is called trig? It is called trig बिकॉज यहाँ पे जो कार्बन है that is carbonyl carbon, doubly bonded carbon. Doubly bonded carbon will have sp2 hybridization, or we can call them as trigonal carbon, trichonial carbon, having 120-degree bond angle. That's why this name is 5-exo trig. Okay? तो ये जो साइक्लाइजेशन होगा उसको बोलते हैं 5-exo trig. The next cyclization is 6-endo dig. So why it is called 6-endo dig? Because here there are 6 atoms which are attached with each other through 6 carbons. Let us say 6, 1, here it is 1, this is 2, 3, 4, 5 and 6. Negatively charged oxygen will attack on terminal carbon, and one of the double bond that will shift from here to the adjacent carbon. So that's why this is basically called as, I want to, we can call them as 6 position here. इसलिए इसको 6 बोला है. Why it is endo? Because the bond which is going to break down, that is a part of heterocyclic ring. क्योंकि 5 और 6 के बीच में जो ट्रिपल बॉन्ड है वो डबल बॉन्ड बन जाएगा, इसलिए उसको बोला है एंडो, क्योंकि वो रिंग का पार्ट है. Why it is called dig? Because ये 6 नंबर का कार्बन है, that is triply bonded carbon. Triply bonded carbon have hybridization sp. sp hybridized carbons have geometry diagonal. Okay, so that's why all these names are given according to Baldwin's rule. 3-exotat, 5-exotrig, 6-endodig. So if you are given these kinds of rules, will you be able to learn that? Answer is yes, you can. That what can be called 3-exotat, 4-exotat, 5-exotat, 6-exotat. All this you can recall. Then 3-exotrig, 4-exotrig, 5, 6 exotrigs. Endo, then similarly 3-endodig, 4-endodig, 5-endodig and 6-endodig. Remember, endo means breaking bond is inside of the new cycle. And exo means breaking bond is outside of the new cycle, or the ring which is going to be formed. Okay. So इसी में Baldwin का rules is there. The figure which is there on your screen, जो भी ये ब्रैकेट्स में, स्क्वायर ब्रैकेट में हाईलाइट हुए हैं, so all these are possible according to J.E. Baldwin. In this path, a trajectory path, attacking path, which are there without rectangular boxes, they are not possible. Not according to me, but according to Dr. Professor J.E. Baldwin. Okay. This rule, I have taken this from Organic Chemistry by Claydon. This image I have also taken from that. And this is also explaining the same thing, that what is called Baldwin's rule. What are the favored and disfavored? आपने ये नाम सुना होगा, what is called Woodward-Hoffman rule for pericyclic reactions, where you might have visited 2 terms. They are called favored and disfavored. तो आपको जो ग्रीन जो भी दिख रहा है इधर, so these all are possible. जो रेड में जो हाईलाइट किया हुआ दिख रहा है रेड रीजन में, दे आर disfavored. I mean to say, how to read them? Phi, exo, then tet. So according to Baldwin's rule, phi, exo, tet is favored. 7, exo, trig is favored. 3, endo, dig is favored. समझ में आ रहा है? ये जो एक्सो का पोर्शन जो भी फेवर्ड वाला है ना, वो इधर लिखा है. एक्सो का नहीं, मतलब सॉरी, एंडो आएगा. ये 3 4 5 6 7 दोनों जगह है. तो ये 3 4 5 6 7 एंडो को एप्लीकेबल है. ये 3 4 5 6 7 एक्सो के लिए है. यू शुड हैव दैट, you should perceive this you should understand, you should interpret this diagram by that only. But 5 endo tat is disfavored, will not occur, ये reaction नहीं होगी. 7 exo dig, this reaction is disfavored, this reaction will not occur. This is what according to Sir J.E. Baldwin. तो अभी आपको समझ में आ रहा है, the things which we have learned, the nomenclature we have learned, that is applicable here, and that will give us some idea that whether particular trajectory, a particular approach will occur or will not be favorable, right? So this is a basis for Baldwin's rule, basically, which was given by this gentleman, is the Baldwin, in the year 1976. That has a huge impact on synthesis of heterocyclic scaffolds. Back to back 2 papers, 2 research publications Baldwin has published, and his team is still having lot of citation. If you refer Google Scholar and these 2 papers, uska dekho citations that is far beyond 1500 citations for one article. Okay. So why these things are there? Why Baldwin has suggested some things is favorable, something is not favorable. जैसे why air traveling is favorable, but why not foot traveling is favorable? Traveling by walking is not favorable from LM to Qutub Minar. And why traveling from Ahmedabad airport to Qutub Minar के नजदीक में जो भी स्टेट है, दिल्ली का या फिर यूपी का, तो that is favorable. उसका क्वेश्चन भी जैसे ये क्विज इस आंसर जो ट्रैवलिंग वाले क्वेश्चन का है, सेम आंसर इधर भी है. तो ये बाल्डविन के दिमाग में आया कहां से ऐसा रूल बनाने का? उसने बहुत सारे बुक्स देखे, लिटरेचर देखे, उसमें चेक किया कि 5 एंडोटिक बनता है, जैसे कि 3 एक्सोटेक एक रिएक्शन देखा, 3 एक्सोटेट हो रहा था, यस दिस रिएक्शन इज पॉसिबल. उसने दूसरा एक ऑब्जर्वेशन, दूसरा लिटरेचर निकाला और उसमें देखा कि हाँ ये रिएक्शन 5 एंडोटैक तो नहीं जा रहा है, सो दिस इज नॉट फेवरेबल. तो दिस वे उसने बहुत सारी स्टडी की, दैट इज कॉल्ड लिटरेचर एनालिसिस, लिटरेचर सर्वे. From that literature survey, he has given this rule for ring closure. Then this is red and green colored one, which highlights rules for ring closure. If you want to refer the depth of this, then go to this reference, Claydon, Organic Chemistry by Claydon, Jonathan Claydon is there. Then Grievous, Warren, Waters. In this, at this page number of this, published in 2009, Oxford University Press, you will find out this figure. Okay. Now let us go ahead with further the Baldwin's rule. Why some trajectories are favorable, why some trajectories are not favorable. Only the reason is that depends upon the angle. Whenever a nucleophile attacks to the electrophile, then always we have certain angle. A tetrahedral carbon, this bond angle is alpha angle, which is shown here, that is 180 degree. For trigonal carbon, this bond angle is 109 degree. For digonal system, means triply bonded carbon, this trajectory angle is 120 degree. That varies for one system to another system. आपने ये तो देखा होगा ना, जो SN2 रिएक्शन है उसमें से एक साइड से अटैक होता है, दूसरे साइड से मॉलिक्यूल चला जाता है, उसको बोलते हैं वाल्डन इन्वर्जन और अम्ब्रेला काइंड ऑफ इन्वर्जन. सेम थिंग इज हियर. कार्बोनाइल ऑक्सीजन होता है और कार्बोनाइल कार्बन होता है, तो सम एलिमेंट इज अटैकिंग. दैट वे दिस इज द एंगल 109 डिग्री. ये जो 109 डिग्री एंगल है ना, दैट इज पब्लिश्ड इन टेट्राहेड्रन जर्नल इन द ईयर 1974. मैं और आप इन दोनों में से कोई इस धरती पे नहीं था, तभी से ये बॉन्ड एंगल जाना जाता है और उसको बोलते हैं, इन दिस वाज गिवन बाय all these interactions are like that only somehow. Uh, so all these interactions are like, now for example, although Baldwin has given this, okay, and some of them are disfavored, whether the interactions are depending upon the length, depending upon the nature of linking chain. It may be enabling this kind of um, some interactions are favored and some of the interactions are unfavored. Okay, so friends, considering this as length and nature of linking chain, favored interactions are there. Why they are disfavored? Because there is some distorted bond angle. There is a long distance, and so it is not possible to reach to the trajectory. That's why it is disfavored. जैसे कभी कभी मानो कि बॉलर का बॉल आया और विराट कोहली ने उतनी टाइम पे अपना बल्ला नहीं घुमाया, तो वही बॉल आगे चल के उसके स्टंप्स में घुस जाएगा। थोड़ा सा वो 1 सेकंड जल्दी कर देता, तो वो बॉल स्टंप्स में जाने के बदले बॉल बाउंड्री के बाहर चला जाता। दैट इज बेसिकली द, आई मीन टू से, ट्रेजेक्टरीज, that optimal trajectory was not achieved in a shorter period of time. महेंद्र सिंह धोनी थोड़ा जल्दी दौड़ता और क्रीज को टच कर लेता, तो इंडिया के पास आज तीसरा वर्ल्ड कप होता। बट नाउ वी डोंट हैव, क्योंकि शॉर्टर पीरियड ऑफ टाइम में वो डिस्टेंस, वो ट्रेजेक्टरी नहीं मिल सकी। So now India hasn't have third World Cup. We have to satisfy with 2 World Cups in hands in cricket. Okay, so this is also like that. Sometimes disfavored bond angles, high too much distances, so the optimal trajectories are not achieved. That's why these are disfavored, whereas these are favored, because optimal distances, optimal trajectories are achieved. Here bond angle is so much weird, distorted, that attack, due to the attack, even cyclization is not possible. Okay, so I hope that I am able to explain you about this. Same thing can be also explained in terms of orbital overlap, जिसका मैंने अभी आपको नाम बोला, बर्गी दुनिज एंगल. So what is that? Phi endo trig, why it is disfavored? Phi endo dig, why it is favored? So this also can be explained through orbital interactions. Okay, so let us go back to this and see, check here. Phi endo dig, phi endo dig. So that is favored. But 6, what was other? Phi endo trig. So phi endo trig. This is disfavored. Why one of them is favored, other is disfavored? Basically, this we can, trig is disfavored and dig is favored. So in such case, the terminal could not interact with other terminal, the reactive terminals. So it will require to bend significantly to achieve the Burgi-Donitz triangle. While in this case, a short distance is also, less distortion is required to access in the plane. Here we could not achieve that between these two terminals, 1, 2, 3, 4, and 5. Here we can achieve 1, 2, 3, 4, and 5. So this way the distance is achieved. Now these orbitals are just like gods. जैसे कि we believe in, let us say, God, whether he is Lord Hanuman, Lord Ganesha, Lord Shivji, or Lord Krishna. None of us, especially you and me, have not seen the God in our lives. But although we believe that yes, if you are a theist, then it is applicable. If you are atheist, आप नास्तिक हो तो ये आपके लिए एप्लीकेबल नहीं है. भगवान और लॉर्ड में, खुदा में, अल्लाह में, गॉड में आपका फेथ है, श्रद्धा है, तो आपके लिए एप्लीकेबल है. नहीं है तो आप मत सुनना इसको. वी हैव नेवर सीन द गॉड. तो neither you or neither me have seen the God. Okay, so that's what basically we want to say. Orbitals are also like that. We have never seen the orbitals. We believe that S orbital is like spherical, P orbital is like dumbbell shape, D orbital is double dumbbell shape, and F orbital is having its own geometry. We believe like this. Okay, so orbital science, this science kind of science is also like that. Okay, and tetrahedral carbon. So you can see that this is a all exo. Now we shall go for one by one. All kind of exotate cyclizations are favorable. इस kind of cyclization को three exotate इसलिए बोला है because this will form three member ring. The bond which is breaking is outside of the ring, and this is a carbon which is tetrahedral in nature. It will form three member ring, aziridine. इसका नाम है aziridine. Okay, and this will form all such kind of alt exo tact interactions are favorable. उसमें जो एक्स का जो लॉन पेयर है वो 3 नंबर के कार्बन के लॉन पेयर के साथ इजीली इंटरेक्ट हो पाता है, और जो भी इसका जो इलेक्ट्रॉन है वो इसके सिग्मा स्टार ऑर्बिटल के साथ अच्छे से इंटरेक्ट हो पाता है. ये ऑल एक्सोटेट इंटरेक्शंस आर फेवरेबल. All exotrig interactions are favorable, whether it is 3 membered, 4 membered, 5 membered, 6 membered, or 10 membered. These interactions are favorable. Again, that trajectory, a kind of electron can interact with empty pi star orbital of this double bond. इसलिए all exotrig are favored. All endodig means whether it is 2 3 to 2 से तो cyclization होता नहीं है, minimum 3 member चाहिए, तो 3 से ही start होता है. 3 endodig, 4 endodig, 5 endodig are favored. In some case, like this, intermolecular versus intramolecular reactions are there. Conjugate addition is like this, but if we have nucleophilic addition, then it will form 5 exotrig. This cyclization is there. Okay, in your examination, I may give certain kind of things like this. And you will have to justify whether such kind of cyclizations is favorable or not. Or else you identify the cyclization. इस cyclization ऐसे होगा तो उसको क्या बोलेंगे? Since it is 5 membered, so it is called 5. Bond breaking is outside of the ring, that's why it is exo. And bond is this term, this carbon, electrophilic carbon is having trigonal geometry, that's why it is called trig. Why, when it comes to 5 endo trig, so bond which is undergoing breakdown, that is a part of the ring, so that's why it is 5 endo trig. With this kinds of exam, this kind of questions which shall be there in your first MCQ days or first or mid-semester examinations. I will ask some questions like this. Question may be there that why one of them is favorable, 5 exotrig is favorable, 5 endotrig is not favorable because of orbital overlap. If we have 5 exotrig orbital overlap, then this interaction is favorable. If we have 5 endotrig, then this interaction is not favorable. So this kind of things can be possible. But sir, I am telling on slide number 18 that 5 endotrig is not favorable, but on slide number 19 I am telling that this is favorable. Why? Because previous was example with nitrogen. This is an example with sulfur. So in the presence of base, this will form a thiolate anion. Thiolate anion can easily attack and can form 5. This is a 5-membered ring, so that's why 5 bond breaking is inside of the ring. That's why it is endo. This is electrophilic carbon, which is having sp2 hybridization. Then that's why it is 3. So here I was telling it is not favored. Here it is favoring 5 endo 3 because here it was nitrogen. Here it is sulfur. तो जरूरी नहीं है कि विराट कोहली को जो बॉल मिला उस पे वो आउट हो जाएगा और सेम बॉल यदि जसप्रीत बुमराह को मिलेगा तो वो छक्का मार देगा. That is possible. Okay. So here there is nitrogen and here is sulfur. So 5-endo-trig was not favorable in case of nitrogen, but the same was favorable in case of sulfur. This has been reported in this paper of 1976. Why? Because sulfur is a element of second row of periodic table. Now periodic table को download करो और check करो. What is this? What are the elements of second row of periodic table? Sulfur will be there. It is having a long radius than nitrogen. The nitrogen and oxygen belongs to same row of periodic table. Sulfur is just below them, below the oxygen, below the level, below the row of nitrogen. और हमें पता है कि जैसे ही हम पीरियोडिक टेबल में एलिमेंट में जैसे ही जितना नीचे जाएंगे एलिमेंट का साइज बढ़ता जाएगा. एलिमेंट का जो एटम है एटमिक साइज दैट विल गो ऑन इंक्रीजिंग. और नाइट्रोजन से ज्यादा सल्फर की है, सल्फर से ज्यादा सिलेनियम की, सिलेनियम से तो उसकी साइज बढ़ती जाएगी क्योंकि एटमिक नंबर बढ़ता जाएगा और दूसरा भी उसके स्ट्रक्चरल प्रॉपर्टीज विल आल्सो इंक्रीज. That's why this is there. Another way it can be also 3D orbitals of sulfur are there, which is empty. That also plays by interacting with pi star orbital of this one. ये जो बोला जाता है कि सल्फर के पास खाली 3D orbital है, which are completely empty. They can also interact with pi star orbital of carbon-carbon double bond. Okay, so these are the things which are there, and so many conceptualized things are there. Directly, let us go to the conclusion. These processes sometimes are favored, sometimes are disfavored, depending upon the size of the ring, geometry, exo and endo nature of the bonds. These structural modifications are there. If they are favored, Baldwin rule is there, and not always necessary. जैसे हम बोलते हैं ना कि कायदा कानून इसलिए बनता है कि वो तोड़ा जा सके. There are so many rules for traffic. There are so many SOPs and guidelines to follow during COVID. Here, so I'm अभी मैंने पहना नहीं है because there is no one here other than me. But when I go to some public places, I will have to wear the mask. Without mask, it is not possible. If police personnel may charge me 1,000 rupees. Then no splitting, no coughing or sneezing in open places, open public places. So they are not allowed. You should wash your hands regularly, and you should use the sanitizers. maintain the social distances, don't go outside of your home after 9 o'clock. These are the rules to keep yourself from safe from COVID-19, novel coronavirus disease. और ये सारे रूल फॉलो करते तो नंबर ऑफ केसेस बढ़ने की बात ही नहीं थी, बट स्टिल द नंबर ऑफ केसेस आर इंक्रीजिंग. व्हाई? बिकॉज वी आर नॉट फॉलोइंग दिस रूल्स. में से एक भी रूल या कोई एक रूल ब्रेक डाउन कर दे, हैंड वॉश नहीं करते, सैनिटाइज नहीं करते, फिर मास्क रखने का कोई फायदा नहीं है. तो इसलिए जैसे आप हम बोलते हैं कि रूल्स आर मेड टू ब्रेक. कायदा कानून इसलिए बनाया गया कि वो तोड़ा जा सके. मैं नहीं कहता हूं कि आप तोड़ो. So I'm not promoting like that. Don't do like that. Sir is telling to not follow this rule. But Baldwin's का वो कोई law नहीं है. It is only a rule. In some of the cases, rules are followed. In some of the cases, rules are not followed. So considering this, we we could also design certain other kind of work as well, where Baldwin's rule has been studied for some of the other concepts, where we can study the ring cyclization of all of these compounds. This work has been basically we previously published in one of the journal of organic chemistry, where the rule for cyclizations or selectivity studies for one compound versus another compound is there. In some of the cases, this 6-exo trig, where X is nitrogen and oxygen, तब ये product बनता था. In some of the cases when X is sulfur, then phenol, it will form different product. So this is also may be studied in context of Baldwin's rule. Okay, so जो आपके why we are studying all these topics? Because whatever the things we are learning, that should have certain utility. इसलिए आपको हम ये पढ़ाते हैं ताकि वो कहीं ना कहीं पे आप उसको एप्लीकेबल कर सको. इसीलिए all the things are being taught to you, and that's why we are studying all these concepts. Okay, so we will restrict ourselves up for this class up to this one, and we'll continue our discussion from this onwards in our coming classes. So thank you everyone. Thank you so much.